SwayamPrabha. Digital India. Educated India.
Well, I welcome you all to the lecture 4 of week 5. In this week, we will be studying the important building block of an automated system, that is microprocessor technology. Let us look at the outline of this lecture. At start of the lecture, we will see the definition of a microprocessor. Then we will see its architecture. It has various elements, how these elements operate. Then we will learn what is the difference between a microcontroller and a microprocessor. The definition of microcontroller will be studied. After that, we will study the microcomputers which we are using for our regular day-to-day activities. At the end of the lecture, we will study about the PLCs, the programmable logic controllers, which are used in the automation industry. Its elements, configuration and operation will be studied in detail. Fine, let us begin. In this lecture, we will be studying various programmable logic devices. In our previous lectures, we have seen the elements of measurement system, such as the sensors and the signal conditioning devices. After that, we have also seen how we can convert the signals from one form to the another form. Now let us look at the fundamentals of programmable logic devices. As the name suggests, the programmable logic devices has two words. These are programmable and logic. The devices which are carrying out logical operations on the data are called as the logic devices. But when we are able to program them, when the users are able to program these logic devices, then we are call them as the programmable logic devices. Programmable means we can teach, we can instruct, we can train these logic devices to carry out a certain set of instructions in the given sequence. So what kind of operations these programmable logic devices are carrying out? They are carrying out various control functions according to the instructions written in its memory. So whatever the commands that we are giving, they are the low-level language commands. We will see what is the meaning of the low-level and the high-level language in the next few slides. The first PLD is the microprocessor. Microprocessor is a digital integrated circuit. It is an electronic circuit and it carries out various digital functions which are necessary to process the information, which are necessary to process the data given to the microprocessor. The microcomputer is utilizing the microprocessor as its CPU, that is a central processing unit, and it contains all functions of a computer. So microcomputer may have memory, it can communicate with the outside world with input-output devices. So here you must note the difference between the processor and a computer. Processor is a simple circuit while computer is a system. It has processor as the CPU, central processing unit. Third, PLD, which is very widely used, which is very important as far as the automated system is concerned, is PLC, that is Programmable Logic Controller. Programmable Logic Controller also incorporates the microprocessor as the central processing unit, and it controls the operations of electromechanical devices. But PLC is working in very harsh condition, so the construction of the PLC must be very rugged, very robust. The general microprocessors which are used in automation industry are the embedded microprocessor. Some of the features of this microprocessor are: first, these kind of microprocessors are dedicated to a specific function, control of a specific function. For example, we want to have an automatic control system to control the temperature of an electric furnace. Here, the function is to control the temperature of the furnace. If the inside temperature of the furnace is above the set value, the microprocessor should cut off the supply of electricity to that electric furnace. So a simple electronic circuitry which is embedded inside the electric furnace is nothing but the embedded microprocessor. So it is dedicated to carry out specific functions. Second feature of the embedded microprocessor is they are self-starting. So the processors are starting on their own. As we switch on the system, the processor will start on its own. Why we are incorporating the microprocessors in automation? As we have seen the definition of automation, that we want to reduce the human intervention. We want to have the no intervention. So to carry out the operations in auto mode, we are taking help of the electronics based circuitry, that is nothing but the microprocessors. These are completely self-contained. The embedded microprocessor has their own memory, may have their own battery backup as well. They may have their own energy source as well. The microprocessor which are used in automation, which are embedded in the products or systems, has their own operating system. So we can say an embedded microprocessor will be dedicated to a specific function. It is self-starting. It doesn't require any human intervention. These are completely self-contained. Everything is there inside the system, and they do have their own operating system. The microprocessor, a multi-purpose programmable device, it basically reads the binary instructions from a storage device that called memory. The memory may be the temporary memory or it may be the permanent memory. So whatever the signals which are getting in will be stored in a temporary memory. The microprocessor process this information as per the need, as per the instructions given in the program. It processes that information according to the instructions and it provides the results as the output. So getting the information, reading the information, and processing the information based upon the instructions given are the functions of a microprocessor. But how these functions are carried out? So to carry out these functions, the microprocessor basically has three elements: the processor, memory element, and input-output devices. To carry out these functions, the microprocessor basically has hardware, and this and the hardware is nothing but the electronic parts which are integrated together to carry out the intended operation. The processor is an electrical circuitry, memory is an electronic part, and input-output devices are the electromechanical parts. Well, these components are integrated together, but their coordinated operation will be carried out by a set of instructions. And that set of instruction is nothing but the program. And when we group together a variety of programs, then we call that as a software. So let us see what this processor does. The processor recognizes the program instructions and it execute that program instructions as per the order given, as per the sequence given. The microprocessor has the input-output interfaces. So the microprocessor is also carrying out the communication between the CPU, that is the processor, and the outside world through the input-output interfaces. So in general, we call the interface as port. In our day-to-day language as well, we are using the word port quite often. The third element which is there, that is a memory. The memory basically holds the program instructions and the data. The applications of microprocessor can be classified basically in two categories. So based upon the applications of the microprocessor, we can say that the microprocessor can be utilized as a reprogrammable system device, such as the microcomputer. So whatever the computing devices that we do have, we can reprogram these systems. We can change its operating system. We can install some programs. We can modify these programs. We can edit the programs. So to carry out these operations in microcomputers, we are using the microprocessor. So when we are using the microprocessor utility for developing the reprogrammable system, that we call the application of microprocessor to have the microcomputers. In the second application, we want to have the dedicated functions that to be carried out by the microprocessor. And these are nothing but the embedded systems which we have already talked about. Let us consider the typical automated systems such as a conveyor belt, automated guided vehicles, automatic furnaces, all the manufacturing industry equipment, whether it may be processing equipment or it is the conveying equipment or it is the monitoring equipment. So whenever we are saying we want to carry out the intended application, the desired application in automatic mode, there also we need the microprocessor. So the application of microprocessor to carry out specific functions in automatic mode, that is nothing but the embedded system. These processors do operate in binary digits, that is 0 and 1. These digits are called bits. If the electrical voltage given to the machine is of low level, then the bit would be 0, and if a high voltage is applied, high electrical energy is applied, then we are considering that as the bit 1. So when we group together these bits, a word is formed, and if the length of the word is 8 bits, then we are calling that word as the byte. If the word length is 4, then we are calling that as nibble. So as already I have talked to you, a command in binary to accomplish a task is nothing but the instruction. Read, write, add, subtract. So many operations the microprocessors are carrying out. The command in binary to accomplish that task is nothing but the instructions that we are giving to the microprocessor. So these instructions can be entered either through input devices or they can be stored in the storage devices itself. So the instructions we can input by using the keyboard, that is a very general input device that we use, or we are using the pointing device and clicking device, nothing but the pointer, is nothing but the mouse. These are all input devices. Or in certain cases, the instructions are embedded, they are stored in the memory of the computer itself. A typical architecture of the microprocessor can be seen on your screen. So as I mentioned, it has the processor. The processor has three parts. First is arithmetic and logic unit, register arrays, and the control unit. The second set of elements is the input-output devices through which the microprocessors are communicating with the outside world. And the third element is the memory. So either we can have the read-only memory, the permanent memory, or we can have the random memory where we can read or write, we can have the erasing operations be possible. So to communicate with these input-output devices and the memory, we required a mechanism, and that mechanism is nothing but the communication mechanism, which is through the wires. Through wires we are passing the electrical signals, and a set of wires is nothing but the bus through which we are communicating with various elements of the microprocessor. The register array has many registers, and these registers are utilized as temporary memory locations through which the microprocessor is carrying out a variety of operations. What operations is it is carrying out? It is carrying out the algebraic operations as well as the logic operations. So algebraic operations are the addition and subtraction, and the logic operations are and, or. The input output devices are called the peripherals. So when we have the central processing unit on a single chip, that is called the microprocessor. So as I mentioned, the arithmetic and logic unit is carrying out the operations such as addition, subtraction. These are the algebraic arithmetic operations, and the logic operations are the and, or operations. The register array is having a set of registers which are acting as temporary storage devices. So whatever the information we are getting from the memory, may be permanent or the random access memory, these information will be stored in a temporary manner inside the CPU itself. Based on the control instructions, the microprocessor is taking this information which is at the temporary storage. It carries out the arithmetic and logic operations on this information which is stored in the register arrays, and it further give the output which is stored in the register array itself. So whatever the results are stored in the register array, that will be taken through the bus, that will be communicated to the output terminal if required, or it will be stored inside the memory. The control unit is carrying out the controlling of the signals or the data to fetch the data through the system bus and apply the set of instructions over that data would be controlled by this control unit. The timings will be set, so it has a clock. It is nothing but a oscillator circuit which we have seen in our the early lecture, that is the piezoelectric based clocks. The clocks are giving signals. The time has over. Now we have to execute the next set of instruction. So accordingly, the processor will take the data, it will process the data and return the data back to the register array. The peripherals, the input peripheral are nothing but the keyboards, or we can have the ADCs, that is analog to digital converters. We have seen in our previous class that the analog to digital converters are converting the analog data into digital format, and that digital format data will be given to the microprocessor in case of it is used for the embedded operations. But if the microprocessor is a part of a microcomputer, then we are inputting the data through the keyboard. If the microprocessor is utilized in a microcontroller, then the output would be given to the actuating device through the signal conditioning device such as DAC, that is a digital to analog converter. But if it is a microcomputer, then the output would be simple display devices such as LEDs, CRTs, or a printer or a magnetic tape. As I mentioned, there are two types of memories are used, that is a read-only memory and the random access memory. In read-only memory, we are storing the programs which we cannot alter. These are the system programs which we are storing. The user cannot change the programs. So some programs like the monitor program or the drivers of the hardware are stored in the read-only memory. The data on the random access memory can easily be changed. Here we are giving the data that to be processed, or even we can have the programs that to be modify or edit. So bus is nothing but a group of wires which are used to communicate the signals among the various elements of the microprocessor system. After studying the definition of a microprocessor, microcomputer, now let us look at the configuration of the microcomputer. On your screen you can see typical arrangement of a variety of elements of a microcomputer. So it has the ALU and control unit. It has the input output devices, these are the peripherals, the memory, and various types of buses. These buses are carrying the digital signals from one section to another section. These are the paths through which we are communicating either the data related to the variable, the instructions to carrying out the controlling operation, or to communicate the address of the data. The bus is nothing but collection of a number of parallel conductors. These are carrying electrical signals, and these buses are being shared by many chips which are integrated in a typical microcomputer. So you might have gone through various configurations of microcomputer based upon the number of bits. So we can call a 16 bits configuration, or 32 bits configuration, or a 64 bits configuration. The meaning is that we can handle 2 raised to power number of bits values by using these communication paths. If the number of bits are 16, that means we can handle 2 raised to power 16 types of values by using this communication path. So as the number of paths are more, we can have the faster communication. In earlier days, there was a serial communication in the microprocessor. The information or the instructions used to pass in a sequential manner. So that's why the microprocessors were very, very slow. With the introduction of the parallel communication by using these wires, now the microprocessors are very fast, very rapid. Each path carries 1 bit of data. There are basically 3 types of buses being used in microprocessor or a microcomputer. The first type of bus is the data bus. The data bus is associated with processing of the information. If we are saying that there is a word length of 4 bits, consider a word of 1010, that means we require 4 parallel wires that to be laid down to communicate this word 1010. So the number of values which can be possible by using this 4-bit data bus, so we can have 2 raised to power 4, that is a 16 number of values can be handled by this data bus. So if you take example of a embedded system which is used to record forces and to process the information about the forces, say automatic way balance machine. So when the force is in between 20 to 180 Newton, we are using this device. This is the range of the device is 20 to 180 Newton capacity. The span would be 160. So as the number of values are only 16, so we can have only 16 segments of the span. So the 16 segments of the span can be handled by this microprocessor or the embedded system. Each segment may have a 10 Newton of the capacity. The 4 bits type of data buses or 4 bits type of the communication systems are quite often used in toys, so automatic toys, very small type of very small variety of information we need to process. But the general computers that we are using nowadays, they do have the capacity of 64 bit, maybe more than that. The next bus is the address bus. It carries the signal which is indicating where the data is to be found out. So it carries the location, it carries the information about the location of the data from which we have to fetch the data, or we have to load the data or write the data in the memory locations. To select a certain memory location at the input or output ports as well. It's not only getting the data from the memory locations at the memory. In the memory, each storage location has a unique identification, and that unique identification is called the address. The next type of bus is the control bus. The control bus is carrying out the signals related to the control actions. So what may be the control action? Say reading the data from the input device. It's basically the function of the microprocessor. Read the data. So it is controlling this operation. Write the data to the output device. And these controlling operations would be carried out based upon a clock. The clock is nothing but a crystal controlled oscillator, which we have already seen in our previous lectures. It produces pulses at regular intervals, and based upon the clock signals, the control bus operations would be carried out by the microprocessor. Well, now see what are the various programmable controllers which are based upon the microprocessor. In the industry, basically PLCs, that is a programmable logic controllers, and the microcontrollers are often being used. These two devices are incorporating microprocessor as their CPU, central processing unit. So what is a microcontroller? The microcontroller has the central processor, it has the memory, and it has the input output ports. So together it is called as the microcontroller. It is implementing the functions of a computer and the controller, but all these functions and all this circuitry is on a single chip. That is the uniqueness of the microcontroller. It is a very small device which can easily embed inside the equipment itself. So all the processing circuitry, memory, and input output ports are manufactured, integrated on a single chip itself. But the capability of microcontroller is limited. It is generally programmed to carry out a few applications, few operations, a simple operation, say control of temperature in an electrical furnace. A simple operation is there to control the temperature. If the set temperature is more than, then cut off it. So for one or two applications, the microcontrollers are used. Again, I'm giving the example of the washing machine. So to control the operations of washing machines, which is having the limited capability, we cannot change its program. It is dedicated to specific control function. So generally microcontrollers are used in automobiles, aircrafts, and medical electronics, and majorly they are being used in the home automation, home appliances. So as I mentioned, they are very small and can be embedded in a electromechanical system without taking up much space. They are space effective, very small, integrated, compact devices. They need very little programmable memory. Memory is also required very less. So some of the standard microcontrollers available in the market can be seen on your screen. These are Motorola 68HC11, Zilog Z8, Intel MC S51 and 96 series. The next type of controller is the programmable logic controller, and it is often used in the, heavy automation industry. We can say that any computer which is having the input output interface which can be used to communicate with the external devices, it's nothing but a programmable logic controller. But what is the difference of a typical PLC with the microcontroller or microcomputer is that the computers or controllers are not industrially hardened. They are not designed to sustain in the harsh conditions in the industry. Harsh conditions may be very high currents, high voltages, high temperature, high humidity, high noise, vibrations. So microcomputers may not sustain this harsh environment. So when we are designing special microprocessor based device which will sustain all these harsh conditions, that is nothing but the programmable logic controller. The PLCs have electrically isolation circuitry. So we have seen one very important isolation circuitry, that is a optical isolators, opto isolators. So these type of isolation circuitries are integrated in the PLC to safeguard the circuitry of the PLC from the harmful signals. A typical definition of the PLC can be seen on your screen. It is a digital electronic device. It uses the programmable memory to store the instructions and to implement the functions such as logic, sequencing, timing, counting, and arithmetic words to control the machines and processes. So I would like to emphasize here that these are very general. These functions are very general. They are there in the microprocessor, in microcomputer, and in microcontroller as well. But when we use these technology especially to control the machines and the processes, then we are calling that device as the programmable logic controller. A schematic of the arrangement of various elements of PLC can be seen on your screen. Here you can notice that the PLC has all the typical elements which are there in a microcomputer. It has microprocessor, communication ports, communication paths, that is a buses, memory. But you just notice that the PLCs has a power supply that is supporting the memory, that is assisting the memory, and that is also assisting the microprocessor. It has inbuilt power supply which is helping the memory and microprocessor to survive. The PLCs have the input-output circuits and dedicated input and industrially hardened output interfaces so that the circuitry of the PLC will be safeguarded. Little more details about the PLCs can be seen on your screen. See, it has all the elements of a typical microprocessor based system, that is CPU, the clock which is controlling the operations of the CPU, the memory elements such as the read-only memory, random access memory, input output units, various buses, input system, address bus system, and the control bus system. But as I mentioned, it has the battery which is supporting the memory, the user program memory here. And the important thing is that we are using opto isolators in the PLC system. The optoisolators are protecting the PLC from very harsh signals. So the input output system is having a buffer, and the buffer is attached to the optoisolator system. If the signals are in acceptable range, they will be buffered in a buffer register, and then through input output system bus it will be communicated inside the circuitry. A typical PLC can be seen. A photograph of a typical PLC can be seen on your screen. So it has the output relay and input relay, output terminals and input terminals. Few more pictures of the PLCs can be seen on your screen. So this is the Mitsubishi FX1S 20MR. You can see the construction of the PLC is very rugged, very robust. Only the interfaces are open to the external world, and the construction is very compact, very strong. We can club together many PLCs and they can be stored in a rack. So on your screen you can see a rack with multiple number of PLCs are stored, they are stationed. So let us summarize the basic functions of the PLCs. The PLC is scanning a set of sensor inputs very rapidly and repetitively. So they are getting the inputs at a very fast rate, and then they evaluate that sensor input. They carry out the logic operations on that, and according to the program written, they are generating the output. So where the PLCs are being used? PLCs are used in automation in open loop. It is a sequential manner. They are also used in the assembly lines in the industry. The PLCs has multiple inputs and they do have the multiple outputs. So the same PLC can be connected to many equipment with multiple inputs can be taken inside, and the output can be given to the actuators or the actuation devices. What are the various advantages of PLCs? The PLC is a very cost effective, it is a flexible, and it has ability to use similar system for other processes. The PLC is not a very dedicated or a special purpose device, it is a general purpose device. So as I mentioned, it is having multiple inputs and multiple output. The same PLC device can be utilized for the other processes provided you have to program it accordingly. It has capability to resist the impact and vibrations. It has very good resistance towards electrical and mechanical noise, and it can be used in very high temperature. So that's why they are very popular, very important in the automation industry. Well, with this, I would like to stop for the introduction to microprocessor technology. Fine, let us summarize this lecture 4. Friends, we have seen the important building block of a typical or mechatronics based automated system, that is microprocessor. We have seen its importance. The microprocessor is the brain of the automated system. We studied the architecture of a microprocessor. We have seen its elements, various modules. The operations of these modules and elements have been studied. After that, we learnt about the microcontroller. The microcontroller, its definition and its difference with the concept of the microprocessor. Then we have also seen the microcomputers, its meaning, and finally we studied the PLCs, that is programmable logic controllers, its elements, configuration and operation. In lecture 5 of week 5, we will go ahead with programming languages which are used in designing of microprocessors. We will have an introduction to the programming languages, the number system, what is the meaning of low level programming language, what is the meaning of assembly language, and in association with that we will have an example, we will have a case study. Till then, goodbye, thank you.